Sarve Jana Sukhna Bhavantu. Hi friends, this is our Dr. BAPUJI PULLEPU alias Dr. BP. See, the previous problem we done 2 by 2 matrices, eigenvalues and eigenvectors. In third video we done how to find the eigenvalues and eigenvectors of 2 by 2 matrix and 3 by 3 matrix. I done same matrix, I hope actually. Now here what you will do you see this finding eigenvalues, eigenvector method up to eigenvalue same story. After that slowly I will do find eigenvector out of it. So to find eigenvalues what I told, write characteristic equation. Characteristic equation is what? Determinant of A minus lambda is equal to 0. So this how you will write A minus lambda is equal to 0 implies in diagonal you can use the minus lambda for diagonal element 2 minus lambda 2 0 2 1 minus lambda 1 minus 7 2 minus 3 minus lambda, sorry, determinant is equal to 0. This already I told you can remember it because this 3 by 3 3 times lambda lambda lambda. If you get the third cubic equation you will get lambda cube minus s1 lambda square plus s2 lambda minus s3 is equal to 0. Who is s1 actually? Sum of the diagonal elements. Diagonal elements only I told you the row number and column number same is, that is called diagonal element 1 1 2 2 3 3. Somebody will tell leading diagonal, principal leading, only one diagonal only. So this I can write actually a11 plus a22 a33. This is the elements position. So is equal to 2 plus 1 minus 3 0. Already yesterday I done, so I am going very fast. S2 is equal to what I told, cofactors of diagonal elements. So C11 plus C22 plus C33. So S2 is equal to what I got. Leave this row, this column. First diagonal element column is 40. That element in stands in which row, which column, that you can leave. So what you will get actually 1 1 2 minus 3 plus for diagonal element this cofactor means what, leave this row, this column. So what you will get 2 0 minus 7 minus 3. Then cofactor of minus 3 what you will get, leave this column and this row 2 2 2 1. So I am skipping actually, if you want you can see the video 3 there I have solved everything. Just I am writing this directly. S2 is equal to minus 13. Just if you want you can check it. That is LKG part, that you can simplification part you can take and do. Now S3 is equal to what? Determinant of A. Then determinant of A what will get? 2 2 0 2 1 1 minus 7 minus 3. This is also I have done in previous video. So what I got actually minus 12 I think so. 12 I got. Now go back and substitute it in my characteristic equation. So equation become what? Shall I rub off here? Getting or not? So if I substituted what I will get here? Lambda cube minus s1 is vanish, s2 is equal to minus 13 lambda, that is plus 12, that is wait that is lambda is this minus actually, just you can check. So plus 12 is equal to 0. This already we solved actually. Lambda is equal to 1 3 minus 4 I got. You can see the video number 3 there I solved clearly the same problem only, not the same type, the same numbers only done. Just you can check once I verify 1 3 minus 4. Okay, then using this eigenvalues I want to find the eigenvectors when lambda is equal to 1. So right, to find eigenvector what you will do, to find eigenvector you can write determinant of, not determinant, sorry, matrices of A minus lambda I into X is equal to 0. Then in matrices on diagonal element you can give minus. I want to see the matrices once. Wait. Two minus lambda, 2, 0, 2, 1 minus lambda, 1, minus 7, 2, minus 3 minus lambda, x1, x2, x3 is equal to 0. Better you can write this matrix, you can keep here. Suppose if I rub off 2, 2, 0, 2, 1, 1, 1, minus 7, 2, minus 3. So I will keep one side, I will use it later. Now we see, this you can take equation A. Now first case is what? When lambda is equal to 1. When lambda is equal to 1, what you will get? 2 minus 1, 1, 2, 0, 2, 0, 1, then minus 7, 2, minus 4. x1, x2, x3. Then take x1 plus 2x2 is equal to 0, 2x1 plus 3 x3 is equal to 0, minus 7x1 plus 2x2 minus 4x3 is equal to 0. See, now only story will start actually. While doing this type problems, if 3 are different equations means okay, or better you can take any 2 different equations, you can find x1, x2, x3. If it is not, sometimes if you will get for repeated eigenvalues means what, in case all may be same thing you will get. That case may be somewhat we do in another way we attack. If it is not there means always you can check which 2 are different. So first 2 if I take a happy I can do, 1 and 3 if I take means what, take. Then what you will do, you can write here x1, x2, x3. Some people they will start from the second element. Already you are 10th standard, you are done using the determinant, but I don't want to. Just you can write coefficient 1, 2, 0. Second element is what? 2, 0, 1. Then you can write x1 by minus x2. For x2 you can give minus. Then is equal to x3. Then x1 means what? Leave this fellow. If you leave this fellow means what? AD minus BC. 2 you will get. x2 means what? Leave this fellow. x2 means leave this. Fully leave this term. So what you will get? AD minus BC. 1 you will get. x3 means what? Leave this. This fully can leave. If you get means what? AD minus BC. This you will get minus 4. So if it any common factor means you can take, remove that. If there is no common factor means you can write. Now cofactor what will become? x1 is equal to 1. This minus is there, carefully you can write minus 1. Sorry, 2 minus 1 minus 4. Then similarly you can go, what is the values? Lambda is equal to 3 you can substitute it. The one value I got. When lambda is equal to 3, that a minus I lambda x you can take equation. Lambda is equal to 3 if you substituted a minus lambda I x is equal to 0 implies in that equation lambda is equal to 3 if you substituted 2 minus 3. 2 minus 3 what you will get? Minus 1, 2, 0, 2, then 1 minus 3. In this place only lambda will get. No, 1 minus 3 will get minus 2. Then 1. Then third fellow is what? Minus 7, 2, minus 3, minus 3. Minus 6 I will get. Getting or not? So I am not, I rubbed this. So if go and see, if your notes is there, just you can write 2 minus lambda, 1 minus lambda, minus 3 minus lambda. So this what you will get actually x1, x2, x3. Then substituted. So first eigenvalues I will write here. 2, minus 1, minus 4. Then if you solve this what you will get again? minus x1 plus 2x2 is equal to 0. Then 2x1 minus 2x2 plus x3 is equal to 0. Minus 7x1 plus 2x2 minus 6x3 is equal to 0. So you write what I told, write x1, x2, x3, take any two equations. These two equations I am taking, minus 1, 2, 0, 2, minus 2, 1. Then you can write x1 by minus x2 by x3 by. x1 means leave this fellow, AD minus BC, 2. x2 means what? Leave this fellow, minus 1. x3 means what? Leave this fellow, 2 minus 4, that is minus 2. So from this x2 is equal to what I got? 2, 1, minus 2. When lambda is equal to 3. Similarly, what you will do when lambda is equal to next to last value is what? Lambda is equal to minus 4. Substituted there. Shall I rub off here? Am I confusing? Then see, if you want, you can pause and see every second, every step is this. When lambda is equal to minus 4, what you will get? 2 minus of minus 4. That is a minus lambda I into x is equal to 0. E is what? 2 minus lambda. So already lambda is minus. 2 minus of minus is what? 6. 2, 0. Then 2, 1 plus 4, 5, 1. Minus 7, 2, minus 3 plus 4, that is 1. Write equations. 6x1 plus 2x2 is equal to 0. 2x1 plus 5x2 plus x3 is equal to 0. If three equations are same means it don't follow, because if you do miss what three equations all miss, already you know any two rows or two columns are equal means determinant is equal to 0 will get means finding is finally determinant, so that will be trivial solution you will get. You don't do this x1 x2 method, that is different method. So this how you will do. So already as I said, right, x1, x2, x3, 6, 2, 0, 2, 5, 1. Then x1 by x2 by minus x2 by is equal to x3 by. x1 means leave this, AD minus BC, 2. x2 means leave this, 6. x3 means leave this, 6 5 is 30, 30 minus 4, 26. Correct or not? 30 minus 4. So if you want, you can cancel throughout what 2 also you can cancel. So taking first two equations, 6, 2, 0, this will get coefficients. What I told, x1 means what? You can leave the first column, then 2 minus 0, 2. x2 means leave second fellow, 6, that is. So minus also there, don't forget it. x3 means leave, then 30 minus 4, 26. Then so in everywhere common 2 is there, this that also you can omit. Then 1 minus 3, 13, x3. Now we can write eigenvalues when lambda is equal to 1, x1 is equal to 2 minus 4 minus 1 minus 4, then lambda is equal to 3, x2 is equal to 2 1 minus 2, when lambda is equal to 1 3 minus 4, I think so. Lambda is equal to minus 4, x3 is equal to 1 minus 3, 13. See the values. Thank you for watching our channel. Kindly share and subscribe. Be part of our service. Inform to all your first year students. We can rapidly grow our channel. Bye. We meet in next video.